The objective of this exercise is to optimize and validate the design of the wheel center in the Formula SAE race car built by the Oklahoma University Sooner racing team. The wheel center is bolted to the drive shaft and the power from the engine is transferred to the wheel assembly by 10 radial arms. We can optimize its shape to remove material where it's not needed to transmit the force. This simplified example of following lines of force shows us that the corner of this flat plate in tension is not experiencing any stress. You can remove that material, saving weight without reducing strength. As you remove material, watch out for areas like sharp corners and tight radiuses, where stress might concentrate and cause your part to fail. On this example of a flat plate in tension, you can see how a sharper radius notch causes higher and more focused stresses. To improve and validate the design of this wheel center part, we will analyze it in the stress analysis environment. Pin constraints are added to the bolt holes, and a frictionless constraint is added to the hole in the center of the part. A moment load of 138 Newton meters is added about the axis of the hole in the wheel center. This is typical of the load you can expect under acceleration. A simulation on the initial design of the wheel center shows a safety factor of 11.68, well within the design criteria. Its current weight is 1.143 kilograms. These results indicate that modifications can be made to the part. To reduce the mass of the wheel center, 3 dimensions will be modified. In the part environment, 3 parameters are created and used to change the dimensions of the wheel center. The parameters control the large and small radii at the base of the arms and the thickness of the arms. To modify the part, a parametric study is created. This allows you to nominate parameters for evaluation, define the parameter range, specify the design constraints, and analyze the results of each parameter variation. An exhaustive set of simulations are run. In this example, 27 different sets of results are created. Dragging the slider for each parameter displays the results for that combination. Upon review, our minimum values for each parameter lead to a safety factor of 6.96 and are within the design criteria. Once you determine that a configuration satisfies your design needs, you can promote that configuration back to the model as a CAD edit. In conclusion, the objective of the exercise was to reduce the mass of the wheel center. The mass of the new design is 0.656 kilograms, 43% lighter than the original. What more can be done to reduce the mass? In this assembly, the overall dimensions are controlled by 2 design criteria: the radius of the wheel and the diameter of the hub around the drive shaft. The stress, displacement, and safety factors are all within the design criteria. However, more meaningful reductions in the mass of the wheel center are prevented by these overall dimensions and the desire for a conservative safety factor to prevent catastrophic failure and injury. It is now just 0.65 kilograms, and further modifications would not represent a significant reduction for the cost and effort required. Now let's review the workflow in more detail.